As the experiment, I have explained everything briefly in the previous session, what you have to do. So if you have any doubts, you can please ask.
Ma'am, could you please summarize the previous session because due to some issues I was not able to connect that with and recording was on there also.
Which one?
Ma'am, previous session actually.
Previous session, the whole experiment do you want?
Only a bit of summary if you can.
Okay. So the part one is, so you guys don't have the recording of the previous experiment,
No, ma'am.
previous session. You guys were not shared.
No, ma'am.
No.
Okay. Okay, fine. I'll give you a brief of it. So first of all, you have to check the transistor characterization. So prefer figure 1. I will share the screen with you. Just a minute. Is it visible to you?
Yes, ma'am.
Yeah. So first of all, you have to check the transistor characterization. So to characterize the behavior of both BJT and MOSFET. Okay. So you guys, you people have the materials. Hopefully, you should have one BJT. Hopefully, I think NPN BJT. I'm not sure what you people have with you. I think NPN BJT with you, N channel MOSFET and one LED. One 1K potentiometer will be there with you. 1 kilo ohm resistor, one breadboard, connecting wires, multimeter, ADLM kit with you. Now, first of all, you have to check what is the transistor characterization. Check the transistor characteristics. Check the output characteristics of the transistor. So you will connect your so both transistor you will connect in this fashion, N channel and N channel MOSFET and BGT here, and then choose an fixed choose an fixed voltage value of VB or VGS of the transistor that will be given in the data sheet of the transistor. Okay, whatever transistor you are being shared with, that transistor will have a data sheet. Give that transistor name in the Google, you will have a data sheet of that transistor. From there you will have those values. You have to choose a appropriate fixed value of VB that will give a particular ID. So measure and record the base current for the fixed VB and VGS using the multimeter or multimeter current probe. So you have to measure IB, measure and then vary the collector emitter voltage. So you have to vary the collector and emitter. So that means VCE voltage by varying VCC. This thing, so by varying VCC from 0 to 5 volt in steps of maybe 0 0.5, 0.2, like that, 0, whatever you want to check. So for each voltage step, you have to measure and record the collector current IC using the multimeter. Now repeat the same thing for MOS. Plot the IC versus VCE value. So you are varying VCC from 0 to 5 volt, measure the VCE value and the corresponding IC value. You will have a plot. That plot you have to show in the experiment video. Same thing you need to repeat for MOS, ID versus VDS value. You will change the VC value and accordingly the VDS will change, the drain source voltage will change and the drain current will change. So 2.5 you can already have, I think you have already one knob in your ADLM in 2.5 VCC. You can take from the kit itself. And RP and RV value you have to just choose appropriately so that it, you can see the transfer characteristics or the output characteristics of the transistors.
RB and RC will be 1 kilo ohm only, no?
Yeah, 1 kilo ohm, 1 kilo ohm, correct.
Okay.
1 kilo ohm resistors are there, and one potentiometer is there, it is connected. So with that you can change the IP value, correct?
Yes, ma'am.
Yeah. Now the second part is BJT driver circuit. So VS you will take from the, please refer figure 2, LED driver circuit using BJT. So the potentiometer is connected across BJT, this VS, and across this potentiometer you will take a RP that will be connected to your BJT transistor or MOSFET. So here there will be a LED connected in the IC, in that collector terminal. So LED and an RC. So what you have to do here, this RC and RB values are already given to you. So I think you have 200 ohm with you and 5 kilo ohm. If you don't have, you have to maybe 100 ohms you have, right? So maybe series that you have to see, and RB value 5 kilo ohm may be used. These are approximate values. If you want, you can change, no problem. So apply 5 volt DC across the potentiometer here. Yes, potential, and adjust this variable voltage terminal to the lowest voltage terminal here. So RP you have to adjust such that it provides very less voltage, lowest voltage. Then gradually increase those voltage. Increase the volt here. If you increase that, this current will change, correct? So gradually increase the voltage output of the potentiometer and observe, and accordingly IC is dependent on IB, right? So the current IC will also change, and accordingly the LED will, brightness level of the LED will also change. Now measure and record the voltages across the collector emitter of the BJT for both off and on conditions of it. Note the voltage across the LED for both the cases. Note the base current for both the cases. Means for on and off conditions, you have to note down the base current value as well. So one thing, you have to measure the base current value, then VCE voltages across, measure and record the voltages across the VCE terminal for both off and on conditions. So for VCE you have to measure, IB you have to measure for on and off conditions. Now remove RB. RB you have to remove when the BJT is on, and note the voltage at the variable terminal of the potentiometer. So you remove the RB and you see the voltage, what is the voltage across the potentiometer. So you have to see, if you open the RB, what will happen to the circuit, how the LED changes, brightness is getting out, it is getting off, or whatever. So you have to check and find out the reason behind it. So the same part 2 you will be repeating with a MOS transistor. Okay, same thing. So just you have to make some changes, that you go through the working principle of MOS transistors, and you will get to know. And you change the MOS transistor, change the BJT with the MOS transistor, and do the same experiment and show the experiment in the, and take some inferences about which one is better, which whether BGT has some advantages over MOS, and what disadvantages has BGT over MOS, or what disadvantages has MOS over BGT. So that all those points you have to note it down, and maybe inform it in the video that will be uploading. Okay. So the last part is the light dependent resistor control LED circuit. So here what you'll do is, in place here you have to connect, refer figure 3 if you can follow. So here you will connect an LDR. So this is a series register. So if you don't want to use a potentiometer, you can use a fixed resistor here, no problem. Just it is just a series register connected to a voltage source. So that is taken out. If you are using a potentiometer, any two terminal, one terminal is this, another terminal is this, and this should be connected to your LDR, light emitting diode. So not a light, sorry, light detecting resistor, dependent resistor, and then that should be connected to your BJT transistor through RB. Now you have to block the light. First of all, block the light and keep the LDR in the dark mode. So LDR has characteristics of how the resistance is uh, uh, vary when it is whether it is exposed to light or it is exposed to darkness. So the resistance will vary accordingly. The current in the base current will change, and also the IC. So that therefore, if you place a hand over the means, make sure the LDR is light and then is dark. You cover the LDR, and then you remove the cover slowly, and you check whether how the brightness changes. Okay, so that's on the brief of the experiment. So hope you are able to follow. Any more questions? Any more doubt? So everyone has started doing the experiment, right?
Yes,
So
ma'am.
you guys are doing the experiment, right? Now I think it has been 3 days. I think 3 or 4 days. It's been past your NSEM exam. I think you guys have started doing the experiment. Correct? So if you have any doubt on the deadlines, so I cannot give you info on the deadlines because that is not decided by me. That is decided by the professor, and I think Victoria will be able to share that with you. Victoria, can you inform them?
Yeah, yeah, tell me.
So they're asking for the deadlines. I think
Deadline is already informed to them. That is on May 5th.
May 5th. Okay.
Yes.
So they are asking something like how means 7th or 8th.
For 4, 5, and 6th week, it is May 5th is the deadline. And for week 7, we will be sharing it with you guys shortly. Once it has been shared, for week 7 and 8, the deadline will be May 15th.
May 15th.
Yeah.
Okay. Okay. So for this experiment, the deadline is May 5th, right?
Yes.
Yeah. Okay. Okay. Thank you. So hopefully everyone has followed Victoria what she has shared. So you have to submit the assignment by May 5th. So if you have any doubt other than that, you can ask me.
I'm a small request.
Yes.
Could you please share the data sheet? Actually, I have just searched in Google and I am just getting 2 or 3 data sheets. So I am not sure about the values of that.
Okay. Which I actually the problem is not problem as such, but I don't know which BJT model has been shared with you. Maybe I will check with Victoria. I'll get to know what components you people have bought. So accordingly, then so you will have a number, right? BJT side there should be written some numbers, correct?
Yes, ma'am. Yes, ma'am.
So type those numbers actually in the Google search. Okay, type that number and then write data sheet. Okay.
Actually, I got data sheets, but
Huh.
the different value are there in two different data sheets. That's why I'm not sure about that. That's why.
Okay. Uh, then give me some time. Maybe I'll just go through it and I just get the what VGT has been shared with you. Then I'll just inform Victoria or I'll just share with you. Is it fine?
Yeah, sure, ma'am.
Yeah.
Thank you.
Thank you. Anybody else have any doubt? I will request all the students to go through the question paper properly, so that sometimes what you are doing is that you are missing some points. You are not showing those points. Maybe this thing you have to do, and you just showed the above 2 points, and the last point you just missed, and that's why it is like you are missing some points there. So that's why I'll request go through the question paper properly, see what is being asked, what needs to be completed, what needs to be shown in the video, because sometimes we need to show the multimeter reading properly to us, otherwise we cannot verify the what all readings that is there. You just write the values in a paper and just show that this is what we have got from the practical evaluation, and this is theoretically calculated. So in that way it is difficult for us to verify. So please show us the multimeter reading while doing the experiment, because as you are already taking videos doing the experiment, so it will be easier for us to verify that as well. So show the multimeter reading or wherever you are doing measure, maybe in the ADLM kit also, that interface you are show that value properly to us, so that we can verify it clearly in your video that will be uploading in the assignment. Am I clear?
Yes, ma'am.
Yeah. Okay. So any more doubts? Victoria, nobody has any doubt. Maybe we'll wait for 5 more minutes and then we can wrap up.
Yeah, there is one chat.
Yeah,
Just
okay.
looking to that.
Okay, I'll just go through. So this question, whether you can directly apply voltage to the gate. So basically, you have very high input impedance at the gate, so you can apply. So you can check that actually what variation, if at all there is any variation. So you can check that and go through the working principle properly and see like why is it there. Not because I told you so that, but you have to go through that why if it is there. Okay, you can apply direct voltage to the gate of the MOSFET or not. You can check it out by yourself. And the I already told it has high input impedance, so you can, but you should also read it by yourself. Any more question?
If there is no other questions, can we wind up?
So if there is no question, shall we conclude?
I think so. We can wind up this session.
Okay. So we'll wind up the session as. Okay. Thank you.
Thank you, ma'am.